In this video, we're going to examine how we can solve a class of equations called quadratic equations using factoring techniques. Finding the solutions to quadratic equations is helpful because it allows us to graph them more accurately, and it can also be useful in solving application problems. Factoring is one technique we have to reveal the zeros of a quadratic. We'll see that the solutions to that quadratic then come from setting those factors equal to 0. This method is useful for quadratics that we can factor. We'll see later on some other techniques that we can use to solve quadratic equations when they don't factor. In order to use factoring as a technique for solving a quadratic equation, we first have to put it in what's called standard form. So we're going to rearrange our quadratic if necessary so that it looks like ax squared plus bx plus c is equal to 0. Once it's in that form, we can factor it, and then we can use the zero product property. The zero product property tells us that anytime two quantities multiply to equal 0, in other words, if we have two quantities a and b, and a times b is equal to 0, then that means that either a is 0 or b is 0. Let's take a look at an example to see how factoring and the zero product property will help us solve quadratics. So here we have the equation x squared minus 5x plus 6 equals 0. It is already in our standard form. So we're going to factor it. We'll use our asterisk method that we've seen previously. If you're unfamiliar with that, go ahead and watch that video. So we're going to do a times, so here's our a, our b, and our c. We're going to do a times c is 6, and b is negative 5. So I'm looking for factors of 6 that add up to negative 5. So factors of 6 are 1 and 6. Now, those can add up to 5 if we use a negative 6 and a positive 1, but then they would not multiply to be positive 6. They would multiply to be negative 6, so that won't work. We also have 2 and 3. If we make those both negative, negative 2 and negative 3, then they multiply to be positive 6 and add up to be negative 5. So those are the ones that we want. So we're going to put our negative 2 here and our negative 3 here. We just have an x. From our first term, remember we drop off the exponent and we keep the a value, so a is 1, so we just write x here. And then if we need to, we simplify, but we have x minus 2 and x minus 3, so those are our factors. So what we have now is that our equation is x minus 2 times x minus 3 equals 0. Now we're going to apply the zero product property. We'll call that ZPP for short. That tells us that when two things multiply to be 0, either the first one is 0 or the second one is 0. In other words, what we now know is that either x minus 2 equals 0 or x minus 3 equals 0. We don't really need those parentheses. Notice that these are two linear equations now, which we can use our linear equation techniques for solving. So we add 2 to both sides, and we get that either x is 2 or we get that x is 3. So the solutions to our quadratic equation are the values 2 and 3, and we can write them, we can use brackets to write our solution set, the values of 2 and 3. All right, let's try another one. So we have 2x squared plus x minus 3 equals 0. We're going to once again use our asterisk method to factor it. So a times c is negative 6 and b is positive 1. So I want factors that multiply to be negative 6 and add up to be 1. So factors of negative 6, we can have 1 and negative 5. Nope. 1 and negative 6, or we could have negative 1 and 6, but those don't add up to be 1. We could also have 2 and negative 3, or negative 2 and 3. This is the pair that adds up to be, that pair adds up to be positive or negative 1. So we actually want this pair, which adds up to be negative 2 plus 3 is positive 1. So we're going to write negative 2 and 3 here. Then we're going to take our first term, but we'll drop off the squared. So we write 2x and 2x. And now we're going to look at these as sort of like fractions, and we're going to simplify them. So 2x and negative 2 have a 2 in common, so we can divide that out. We get x and negative 1. 2 and 3 have nothing in common, so we just leave that alone. And so we see that our factors are x minus 1 and 2x plus 3 equals 0. Now we use the zero product property, and we get that either x minus 1 is 0 or 2x plus 3 is 0. And on the left, we get then that x is 1, or on the right, we'll subtract 3 from both sides. Divide by 2, we get that x is negative 3 halves. So our solution set is, the terrible bracket, is 1 and negative 3 halves. Those are our solutions. Let's check them. It's always a good idea when you're solving an equation to check. So what we're going to do is we're going to plug each of those in for x in our original equation and see if we get 0. So when we plug in 1, we get 2 times 1 squared plus 1 minus 3. Well, that is 2 plus 1 minus 3, which does in fact equal 0. So that solution checked. And then we'll do the next one. We get 2 times negative 3 halves squared. We're going to have to work a little harder on this one. Plus negative 3 halves, which is the same as minus 3 halves, minus 3. That is 2 times negative 3 halves squared. Remember, when we square a negative, we get a positive, so that's 2 times 9/4 minus 3 halves. I'm going to rewrite 3 as 6 halves so that I make my life a little easier. So now I have minus 6 halves. That is, the 2 and the 4 cancel. I get a 2 there, so I get 9 halves minus 3 halves minus 6 halves, which is in fact 0, and that solution checks as well. Let's try another one. Here we have 6x squared plus 11x plus 3 equals 0. If you've recently watched the factoring video, you might recognize this factorization. So we do 6 times 3 is positive 18. B is 11, so we're looking for factors of 18 that add up to 11. We can use 1 and 18, or those don't add up to 11. We could use 2 and 9. Those are going to work. 3 and 6 won't work. Those add up to 9. So 2 and 9 work, so we'll put a 2 here and a 9 there. We'll write our 6x above those, and now we're going to simplify. So I'm looking at 6x and 2. They're both divisible by 2. If I divide out the 2, I get 3x and 1. 6x and 9 are both divisible by 3. If I divide by 3, I get 2x and 3. And so my factors are 3x plus 1 and 2x plus 3, and that equals 0. That gives us, by the zero product property, that tells us that 3x plus 1 is 0, or 2x plus 3 is 0. We'll use our linear equation tools to solve these. So we subtract 1 from both sides on the left. We get 3x is negative 1, so x is negative 1/3. And over here we subtract 3, we get 2x is negative 3, so x is negative 3 halves. We'll check again. We have 6 times negative 1/3 squared plus 11 times negative 1/3 plus 3 when we plug in negative 1/3 for x. So that's 6 times negative 1/3 squared is positive 1/9 minus 11/3 plus, I'm going to rewrite 3. 3 is the same as 9/3. I'm trying to get a common denominator here. Hopefully thirds will work for us, so I get plus 9/3. The 6 and the 9, I can divide them both by 3 to get 2 and 3. So I get 2/3 minus 11/3 plus 9/3, which is in fact 0. So that solution checked. And then we'll check negative 3 halves. So we get 6 times negative 3 halves squared plus 11 times negative 3 halves plus 3. That is 6 times 9/4 minus 33 halves. 3 is 6 halves. So I'll put plus 6 halves here. The 6 and the 4 are both divisible by 2, so we rewrite that as 3 and 2. And we get 27 halves minus 33 halves plus 6 halves. And since 27 plus 6 is 33, this does in fact equal 0. And these have both checked. So our solutions are the set, again, terrible bracket, negative 1/3, negative 3/2. Let's do one more to wrap these up. So we have 5x squared minus 18x plus 9. This is actually not written as an equation. So let's make it a quadratic equation by setting equal to 0, and we're not going to factor that. We're going to solve that. All right, so to solve that, we're going to factor first. So we get 5x squared. 5 times 9 is 45. And we have negative 18. So now we want factors of 45 that add up to be negative 18. Since they multiply to be positive 45, they both have to have the same sign. So they're both going to need to be negative in order to give us a negative 18. So factors of 45, we have 1 and 45. Those do not add up to 18. And again, they both need to be negative. We also have negative 3 and negative 15, which looks like the right pair because those add up to be negative 18. So we'll do negative 3 and negative 15. Then we'll put 5x here and 5x here. Notice at the left side, there's no simplification. We leave those alone. Over here, 5x and negative 15 are both divisible by 5. So we get x and negative 3. So our factorization is 5x minus 3 and x minus 3. And that is going to equal 0. Now we use the zero product property. So that tells us that the first factor is equal to 0, or the second factor is equal to 0. Solving each of those, we get 5x equals 3, so x is 3/5, or we get that x is equal to 3. We'll check. Checking 3/5, we get 5 times 3/5 squared minus 18 times 3/5 plus 9. That is 5 times 9 over 25. Minus 18 times 3 is 54. 5 over 5, and 9 rewritten as fifths is going to be 45 fifths. The 5 and the 25 cancel to simplify, so we get 9 fifths minus 54 fifths plus 45 fifths. 9 and 45 make 54, so this is in fact 0, and that solution checks. X equals 3 is going to be a little easier on us. We get 5 times 3 squared minus 18 times 3 plus 9. That's 5 times 9, which is 45, minus 54 plus 9, which is in fact 0. And so we see that our solution is the set of numbers 3/5 and 3. So what we've seen here is that factoring is an efficient method for solving quadratic equations when it's possible. The zero product property is the thing that makes it possible for us to solve factorable quadratics, because once we've factored, we can then set each factor equal to 0. However, it's important to remember that not all quadratics are going to factor nicely, so we're going to need a few other techniques in order to solve those. The next one we're going to take a look at is something called the square root method.